Good morning, everyone. My name is Prachi Bora, and I'm a program manager on the Visual Studio team. My team does testing tools in Visual Studio, and we cover the entire gamut of testing practices, be it test case management, manual testing tools, UI testing, unit testing, load testing, you name it, we have a solution in Visual Studio for it. Ever since Windows 8 shipped a few months ago, we've seen a great number of apps on the Windows Store. And shipping a great quality app to the store has several different aspects to it. One of the aspects that I'm going to talk about today is the quality of your app. And by quality, I mean three things. One, that you've tested your app thoroughly to flush out all the bugs. Two, you've actually fixed all the bugs that you found. And three, you have some kind of system in place which will help you do enhancements to your app while making sure that the enhancements that you're making actually remain regression-free. So, which is why I'm here today. I come from the testing background, and I'm going to be talking about automated testing of XAML-based Windows Store apps. The agenda for today is really simple. In the first half of the session, I'm going to be talking about the unit testing capabilities in Windows Store that the XAML apps can take advantage of. And in the second half, I'll switch gears and cover automated UI testing using the coded UI test feature in VS. Out of curiosity, how many of you do unit testing for your store apps? Okay, a good number. How many of you do automated UI testing? Okay, so those of you who raised hands, what tools do you use? Test Studio, okay. I'm sorry? Coded UI? Oh, I would love to know how you do that, because this is the first time that we are introducing coded UI support for store apps. I have a lot of exciting demos to show you, so we'll do questions at the end. Since we are talking about testing an app, we'll take a quick tour of the app that I'm going to test today. The app I have is AdventureWorks Shopper app. It's a shopping application that lets me buy bicycles and related accessories. The code for this app is actually available on code samples on MSDN. It ships as part of Prism for the Windows runtime. Prism is a great guidance that was created by Patterns and Practices team at Microsoft, and it helps developers create rich and maintainable applications. So apart from the usual concerns that a store app has, for example, how do I do lifecycle management, navigation, notifications, styles, charms integration, et cetera, Prism also helps you implement MVVM, the model view model design pattern that helps you separate your concerns so that you can have an easily maintainable app. And in addition to that, it's also a guide to creating accessible apps. With this, your app can actually be used by differently abled people successfully. And as we go through the session, you will see why this is important when it comes to automated testing as well. So let's look at my app in action. I have the AdventureWorks installed here. I have this home page wherein I can select items. I can add them to the cart. I can view my cart. I have a nav bar. I can do settings charm, which helps me do login and some user profile management. And I also have search integration. Basically everything that you would expect out of a guide that was created for developing store apps, right? So let's go ahead and close this for now. And talk about what are you going to need for doing the unit testing framework capabilities that I'm going to talk about today. You need Windows 8 or newer, and you need Visual Studio 2012 Update 2 or newer. Unit testing capabilities ship in Win8 Express, Pro, Premium, and Ultimate editions. So you can take advantage of the unit testing capabilities depending on whichever editions you have. Even though it says Windows 8 and VS 2012, I encourage that you try out 8.1 and 2013 preview so that you can take advantage of the other capabilities that come with the product. So let's go back to my demo. The way to create a unit test project for your Windows Store app is really simple. I have Visual Studio here, so I'm going to do File, New Project, and under the Windows Store node, you will see Unit Test Library Template. I can go ahead and create a new project. I have one created already, and you will notice here that I have package.appxmanifest. That sounds familiar. That actually gets created when you create a Windows Store app as well. And the reason we do that is your unit tests are actually testing the capabilities that are within your app. So if your app runs certain things, your unit tests also need the same capabilities to execute because it's going to run in the context of the app. So you would have to declare the necessary capabilities here. And when you build your unit test project, the output will actually be an AppX. So let's close that, and let's look at unit tests for my AdventureWorks app. I have written a bunch of tests already. There's a lot of code here. So in the interest of time, I'm going to walk through what I have. Windows Store apps, fluid and fast Windows Store apps use async programming capability all over the place. So if your app uses async methods, it logically follows that your unit testing framework should have the capability that lets you actually test these async methods, which means that I'll do some pre-processing or the arrange part of my unit test first. Then in my act part of unit test, I'm actually going to call that async method and wait for the results to come back. And finally, I'll assert on the results that came back from that async method. So that's exactly what I'm doing here in my unit test. First thing to note, my test method returns an async task. Let's take a look at what my test is all about, right? My AdventureWorks app let me actually add a bunch of items to my shopping cart. And when I go to checkout, if I'm not a logged in user, it's going to first prompt me to sign in to the app. You can see this in the XAML that this sign-in control is actually overlaid over the checkout summary checkout summary page, right? So that's exactly the functionality that I'm going to test. That I'll call into my shopping cart, and I'm going to execute the checkout command. So let's take a look at what this checkout command does. F12, go to definition, and this command maps to this checkout async method. So the first thing this checkout async method does is it calls into this account service and looks to verify the user in an async fashion. So that's the part that I'm going to test. And what happens here is that if the user is not logged in, then the sign-in user is going to be called, and basically the open on that page is going to get called. I have the MVVM used in my app all over the place. So let's go back to my unit test and look at what I'm doing here. In order to make sure that my unit test is actually only testing the unit that I'm interested in testing, I've isolated dependencies by creating a bunch of stubs that are required by this shopping cart, right? So I have a stub account service here, and what the stub account service does is when verify user authentication is called, it's just going to return a pre-computed result to say that no user was logged in. Armed with that, I can then go ahead and call this shopping cart. Apart from that, I also have a stub for my sign-in page, right? So the sign-in user control, basically what this does is when the open method is called on it, it's going to set a flag saying, yes, sign-in was called. And after I do my checkout command, I'm going to validate that this sign-in called is actually set to true. One thing to note here is that the fakes framework is not available for Windows Store apps today. So all the stubs that are shown here were actually hand-coded by implementing the necessary interfaces. So my test is ready. Let's go ahead and execute that from the Test Explorer. This is my test here. Right-click, run selected test, build has started, and the test will execute shortly, and success. You can see this with this little green top bar, the green check mark here as well, and at the bottom, the test has passed, and it tells you how long it took to execute. So great. I can now test async methods using unit tests. If I can test async methods using unit tests, my async methods may sometime actually throw exceptions. And those may be expected exceptions in certain conditions. If I can validate the results that came back from an async method, I should also be able to validate that the expected exceptions actually are getting thrown correctly, right? So that's the next thing that I wanted to show here. So the first one sort of tried to show the sign-in page. The second test that I'm doing here is if a user cannot be logged in for some reason, then I'm expecting a certain type of exception, and I'm going to validate that. Again, I'm using a stub identity service. The identity service is a service that backs my app, that manages users and validates users and stuff like that. Again, I'm going to have use a pre-computed result here. When the logon async method on the identity service is called, I'm just going to say, return a pre-computed result to say no user is logged in and return null. So let's take a look at what this sign-in user async does. F12, go to definition, and the first thing it does is it's going to call the identity service logon method. It takes the result and then does a bunch of stuff with the result. Notice that I'm not doing any validation on the result here. So if at any given point in time, the identity service returns me a null, I'm going to have null reference exceptions being thrown. Of course, it's a bug in my app, but for the purposes of this demo, let's assume that I'm expecting it and test that. So the pre-computed result here that I got from my stub identity service is actually returning me null, and I'm good to go. The syntax to note here is I'm calling my async method, and this async lambda, I'm expecting it to throw exception. And I'm going to say async assert dot throws exception and the type of exception that I'm expecting. And since it's an async method, I'm just going to await on it, right? The ability to validate that expected exceptions were thrown have always existed for the synchronous case. So we've created this new class in the unit test framework .app container in the unit test framework .app container namespace. Since there could be confusion with the synchronous assert and the asynchronous assert, I've just called it async assert, and that's what I'm going to use here. Let's go ahead and run this test. Building, about to execute, and success again. Great. So let's switch tracks a little bit from the asynchronous stuff. Let's say I do a bunch of validation in my in my app, and any kind of data can be really passed to my app, right? And I want to test various conditions of that data in my app. One way to do that would be to write tens of test methods that just takes in each of those inputs, validates, and then spits it back. An easier way to do would be to data drive your test method. So you have a test method that takes in a bunch of data from the test framework, does its business, and then returns you the result. And data driving your unit tests is as simple as adding this data row attribute to your test method, right? So what this data row does is that you can actually pass in as many parameters as you want, and all of these parameters are going to be passed into your test method. So the only requirement here is that everything that you pass in here to the data row be the same set of parameters that your test method is expecting, right? In my test here, I'm going to validate the address of a user that logs into AdventureWorks. So that's the validation I'm doing. I'm going to take the first name, middle name, street address, zip code, et cetera, et cetera. There's a display name parameter that also gets passed, and we'll come back to what happens there. So again, since I'm doing data validation, I'm going to run this test on my data model. I have a model created for address. Let's go take a look at what that does. So address has a bunch of fields. For example, first name. If you look at first name, it has been attributed as a required field, and it is expected to match certain regular expressions. If I look at middle initial, there's a regular expression that I'm expecting, but it's not really required. So on and so forth with all the rest of the fields in my address. So I build a model with everything that was passed in to my test, and then I call into the bindable validator. The bindable validator is basically a validating class that implements the iNotify property changed interface. And let's look at what the validate properties does. What this is going to do is that it's just going to obtain the entity to validate, which was the parameter that you passed to it. And for each of the properties that are defined on that entity, in our case, the first name, last name, address, zip code, etc., it's just going to run validation and return some errors if there are any errors found. And these validations will actually be run based on the annotations that we saw in the address class, which was the required, matching a regular expression, etc., etc. Right? So let's take a look at a cool thing here. You might have already seen the code lengths feature. It gives you the context of your code, who changed it last, if you're on source control, how many methods are referencing it. In addition to all that, we also provide you the test context. Notice here, let me zoom in. Currently, it's saying 2 of 2 passing because I just validated that my tests were running before we started the demo. Depending on the number of tests I would have, all the tests would actually appear here. And I don't need to really go back to the test explorer to run my tests. I could just execute them from here. So I'm just going to say valid customer info. This is the method that I wanted to run. And I'll hit run. Zoom back. And it's going to execute. And notice in Test Explorer that my test has run successfully. Let's go back to my unit test. My test method was annotated twice with the data row attribute. So my test method was actually called twice. And the display name that I provided here is actually used to tag the test case that was run. So you can easily identify which test case corresponds to which data row. Likewise, I have an invalid customer info. And what this does is I was expecting the first name to be not having any numbers, just matching a particular regular expression. In this case, I'm expecting the street address to be not null, so I could just go ahead and run this guy as well. It does exact same thing that the previous one does, except that I'm just going to assert that validate properties returns false, and there are greater than 0 errors here. And this test has also run, and again, I have the annotations here. Okay, great. So I did async. I'm able to data drive my test. What if I had a cool new idea that I wanted to bring to the unit testing framework that Visual Studio does not support out of the box? Earlier, we did not have a great extensibility model, so your cool new idea would stay with you. Not the case anymore. We have introduced an extension point, which you can go ahead and implement easily to bring your new cool idea into Visual Studio unit testing framework. Deriving from the data row concept that we saw earlier, if I had a bunch of data being passed and I wanted to do a range testing, right, that my data that I'm expecting to drive my test method starts from a certain value, goes up to a certain value, and does that in certain increments, right? With the data row, I would just have to write those number of steps n number of times. So I wanted to implement the concept of range and have unit test framework execute that. So I have written my own classes using the extensibility that unit test exposes. So in this case, my test method has been attributed with two things. I'm passing it some range data, and I'm also calling it the range test method. So let's take a look at what range does. Range attribute just derives from attribute, and what this does is takes in from, to, and step values, right? For a given range and increment values, it's just going to compute the number of possibilities, and for each of these possibilities, it's just going to compute the value for that possibility. So that's all really that the range attribute does. I have a bunch of overloads that takes in different data types, but it all does the same thing. The range test method is where all the action happens. So F12, the range test method attribute derives from test method attribute, which basically means that unit testing framework is going to understand this, and when this test method gets executed, it is going to hook into the unit testing framework to actually do the execution. But then you have control over how things get executed. All you need to do is override this execute method. Since you're overriding it, you're free to do any kind of pre-processing on the data that you want to pass to the execution. What my method does here is it gets all the range attributes that I have defined for my test method. It does a bunch of validation to make sure that the range data that I have passed is correct. It's going to obtain the range data for all the parameters that were passed. Remember, my range attribute acts only on one attribute or one parameter at a time. So in this case, I'm just going to get the ranges for all the parameters that were passed to my test method. And with that, I'm going to do some combination strategy. So if I had x and y as two parameters that are being passed to my test, and x can take two values, x1 and x2, based on the ranges that I have defined, and y can take y1 and y2 as, again, the two values based on the range that I have defined for y, my combination strategy is going to do two tuples, x1, y1, x1, y2, x2, y1, and x2, y2. So in all, four possibilities would be returned by this combination strategy get test cases. Once I have all my test cases enumerated, I'm just going to execute my test. And all that I need to do here is do test method dot invoke. And this invoke is actually going to hook into the MS test framework, execute the test method for you, bring back the results. I've done all the pre-processing with my range data, and my post-processing is here to make sure that my result is annotated correctly. In my result, I want to show what arguments were passed, so I'm just going to annotate it with the arguments that my test method executed. Right? So let's go back to the unit tests and run this test. What this test does is it takes x and y. I'm passing parameter x, which is here, and then parameter y, which is here, and the range for x goes from 10 to 20 in increments of 2, and y goes from 1 to 13 in increments of 2, which means 6 possibilities for x and 7 different possibilities for y. And my method, all it does really is verifies that the sum of x and y is actually an odd number, so modulo 2 would give me a remainder of 1. Let's go ahead and run that, and it's going to execute. So as I said, 6 possibilities for x, 7 possibilities for y. I'm expecting 42 test cases to be run with this. And you can see I have a long list of results here, and test case 42 was executed. Right? So any cool new idea you have the ability to hook into MS Test Framework. Not only that, you can actually share it with your friends or with the community, because we enable you to do a NuGet package out of it and distribute. The data row capability that I showed earlier has actually been built on top of the extensibility framework itself. If you look at this annotation of data test method, if I do F12 on this, even this guy is actually overriding the execute method of the test method. So we've already gone through the demos. A quick recap. In the unit testing framework, we saw how to do testing of async methods. I have code snippets here so that you can have a refresher on the syntax, etc. after you go back home. We looked at inline data driving possibilities, and we looked at the extensible MS test framework. So that's all that I had for unit testing today. Let's switch gears and talk about coded UI test. For coded UI test, all the capabilities that I'm going to demonstrate today, you will need Windows 8.1 and Visual Studio 2013 preview. Coded UI test ships as part of Premium and Ultimate editions, so that's what you're going to need. Let's switch over to my demo machine and do a new blank project. Again, really simple to create a new project for doing UI testing of your store apps. I do new project, and under the Windows Store node, I have a new template for coded UI test project. Can go ahead and select that, click OK. And as the project gets created, I'm prompted with this dialog that helps me generate code. If you are an expert user of coded UI test, a lot of people may prefer to actually manually edit the test, in which case you can go ahead and select the second option. A lot of developers also love to use the coded UI test builder capability, which helps you identify controls on the screen and automatically generate some code, and then you can build on top of that. So let's take that route today. I'm going to keep the default. Click OK. Let me go ahead and get rid of this magnifier here. Clicked OK. Visual Studio was minimized. See this little tool in the bottom right corner? This is the coded UI test builder. And there's this crosshair tool that will help you identify controls on your screen, and you can start building your test. If you are familiar with coded UI test in the context of other applications like WinForms, WPF, or web apps, you will notice that when I hover over this button, it's supposed to tell me that recording is not supported. So we do have recording capability for other technologies. For lack of time and priority reasons, we could not get in recording capability for Windows Store apps just yet. It's on the backlog. But you can still generate some code using this crosshair tool. All you need to do is just on the control of your interest, drag and drop this crosshair tool. It will highlight that control in blue, and it will start to show you the properties of that control. If you don't want to do that drag and drop business, you can also do Control I after hovering over a control, and it's just going to highlight that control for you and show its properties. So I'm interested in testing the AdventureWorks app. So let me go back and do Control I on that one. And I can see a bunch of properties that are lighting up here. It tells me that the control type is a list item. There's an interesting one called Automation ID. And if I look at the value of it, it's a really long string. We'll use this string. Just remember that when I hovered over the tile, I was shown a long string with Automation ID. Automation ID and name, for example, are accessible properties that coded UI test uses in order to uniquely identify your controls. So if you have set these properties correctly in your app, coded UI test will be easily able to identify the control on the screen and act upon them. We call these the search properties. If for some reason multiple controls have the same search properties, then we have a set of filter properties. For example, instance. So if I had 3 buttons and I wanted the second button, I would say instance is equal to 2. Search properties just help you locate your controls faster. So we recommend that you set your accessibility properties correctly, and that is just going to help coded UI test run faster. Let's take a look on this side. What this pane shows me is the hierarchy in which the control appears. So it starts with the start menu, the list of tiles here, and then within that there's a group, and then finally my tile item, right? And I like everything that I see here. This is really the control that I was interested in. I can go ahead and add it to my UI map. UI map is a repository of sorts where you define all the controls, and all the properties that we are seeing here, the search properties, the automation ID, name, etc., are getting recorded. So I have done this. I can also do this within my app. So let's say I wanted to test this back button. I could do Control-Shift-I as well. It's just going to add it directly to my UI map. And likewise, I can do this for all sorts of controls, right? So I'll build my UI map. From here, I can also add assertions on the controls. Oops. I can highlight the property that I want to assert on, and I can do add assertion, and it will automatically add the code to assert on these properties. So as I build my thing, I can now generate code. I'll just say generate. It's going to do a bunch of processing, generate some code automatically. I can go ahead and close it now. Let's take a look at what happened behind the scenes. Here, a UI map.UI test file was created. I can expand and see everything that I added to my UI map using the builder is now available. I can also take a look at the code that was generated behind. So I had done the back button, and you can now see that the back button is actually being identified as a XAML button. We have added a bunch of new specialized classes to identify XAML controls, and all of these are prefixed with XAML. And so you have XAML buttons, XAML windows, XAML list, what have you. The search property for that control the automation ID has been set correctly as it was identified from the UI. And all the controls basically got some code generated. All the code has been generated for me. I'm now ready to write my test. So let's go ahead and close this. I have a pre-canned test that I'm going to use for this today. Go ahead and open that one. The XAML APIs, the specialized controls that I talked about, are available in the Windows Runtime Controls namespace. You will also see that there's a UI testing.html controls. So if your application had a web view control that hosted a bunch of HTML content and you wanted to validate that, we would identify them as HTML controls correctly and generate the appropriate classes. So let's take a look at the first scenario that I'm trying to automate in my coded UI test. I go to my app. What I'm trying to do here is I have launched my app. If I'm not already on the home page, I'll actually navigate to the home page. I'll add the first item that appears here to the cart. While I'm on this page, I'm going to grab this price because I want to make sure that my shopping cart actually charges me correctly. I'll take this, I'll add to cart, I'll go to my shopping cart, I'll validate that this total is the same as what was on the previous page, and then I'm just going to clean up by removing the item from the shopping cart. Right? So let's go ahead and close this and take a look at the test code. Let's ignore this first line for a moment. We'll come back to it. There are several ways to launch the app. You could actually tap on the tile. We have added support for gestures. So earlier you could just do mouse and keyboard actions. Now we have support for gestures. So all the gestures, tap, swipe, slide, flick, rotate, etc. are now supported. So you could actually tap on the tile to bring up your app, or you could call this specialized API called launch and take a look at the parameter that it takes in. Right? So remember that when we hovered over the tile, we got that automation ID. That's basically the string that I'm passing here. And it's not only the automation ID, it's also the unique identifier of my app, of my store app when it gets installed. This is exactly how Windows identifies your app uniquely. So that's the identifier that I'm going to use. I'll bring up the home page, validate that if I'm not already on the home page, I'll bring that up. I'm going to do a mouse click on the first item to bring up the details. I had that first bicycle here, so I'm just going to click on its image, bring up the details. At this stage, I'm going to grab the price of that item, store it as the expected total, and then I will look at the shopping cart. Right? So notice I'm using mouse click here, and I'm using gesture.tap here. This is just to show you that both work equally well. Let's ignore the draw highlight, this troubleshooting comment for a moment. And once I have the shopping cart, I'm just going to assert on the expected total that I got here with the total value that was displayed in the shopping cart pane. After I'm done with that, I'll just remove the item from the shopping cart, select it, my bottom app bar comes up. I'll just remove it and then again verify that my expected total is now 0. Finally, I'll close the app. Let's go ahead and run this test. Right-click, run selected tests. It's going to build, and the app has started. It's going to now verify that whether I'm on the home page or not. It went to the home page, clicked an item. Notice that blue rectangle that I have here. This is actually coming from the draw highlight method that I had in my test. Draw highlight is often used by coded UI test users as a troubleshooting means, as a quick troubleshooting means to verify that the controls are being identified correctly while the test is being executed. And the other reason that I've used here today is if I had not added that, my demo would have just zoomed past and you would not have really seen the action. So draw highlight also draws a highlight around the control and waits for a little bit before the test executes further. So my test has passed. Now let's go ahead and look at what this guy did, right? Here I can see an output line. I'll go ahead and click on that, and this seems to be an HTML file. So I'll bring that up, and what this has is a full log of all the actions that happened in my coded UI test, right? Not only does it have textual action, there's also screenshots of everything that has happened. I can zoom in on the screenshot, and what this has, it's just captured my screen state, and it has also highlighted the control that was acted upon in that particular action. So it's a great way to troubleshoot if my test is not working correctly. Notice that it's also expensive to actually be taking these screenshots. So we do not turn this on by default, which is why I had this logger override state to say HTML logger, which is the HTML log feature, should take snapshots of all the actions that are happening here. So that's basically testing my add to shopping cart scenario. Then I have a little cool demo here, which is the multi-touch gesture demo. My home page on the app actually has a semantic zoom control that I'm going to pinch, and that's really the demo, right? So let's take a look at the code. What I'm doing here is on the semantic zoom control, I'm identifying the bounding rectangle, which are the coordinates that actually bound my control. And based on those coordinates, I'm just going to identify 2 points from the bottom left and the top right, just a little bit inside, and then pinch a little bit to make sure that my control zooms out. So with this data, I'm just going to call gesture.pinch, and I'll be good to go. And when my control has zoomed out, I'm going to verify that there are 5 items actually being shown in the zoomed out view, right? So let's go ahead and run this demo as well. Building test will start shortly. Come on. Okay. Notice in this one, I'm actually tapping on the tile to bring up my app, right? So again, it's not on the home page, so it will first navigate to the home page, and now it's pinching, it validated, and we're good to go. Your Windows Store app may actually have a bunch of integration with the charms, the settings charm, the search charm, etc. All the controls that actually appear on the settings charm, for example, or even that tile on the start screen are not XAML controls. So we do have some specialized classes for that. These shell controls, we call them the direct UI control. So at the top, you would see UI testing has this new namespace of direct UI controls. And if I were to look at a button here, for example, in the designer.cs, the UI login button, you will see that this has been identified as a special direct UI control. The rest of the identification for the control really remains the same. We use the same automation ID or name, those kind of search properties, accessibility properties to identify the control. And it's a specialized class that lets you do rich APIs. So in my settings charm test, let's take a look at the app. I bring up the settings charm. There's login functionality, so I'm going to click on login. I will enter the username, password. I'll click on submit. I'll then verify that my login button has now actually become logout. I'll verify that, and then I'll clean up by doing this logout, right? So let's go ahead and close the app. Take a look at the code. I've launched my app, again the same method, the launch API. I'm going to bring up the charms by doing a send keys of Windows I. And then I'm going to tap on the relevant buttons, set the text, user password, click on the submit button, and bring up the settings charm all over again. And then I'm going to verify that the button shows logout. One interesting thing to note here is that I'm actually using the same login button. My app, what it does is that it uses the same control, just changes the display text, right? So when I built my test using the builder, it identified as the same control. So what I'm going to do now is, instead of just verifying this, I'm going to wait for the control to be ready. And the property that I'm going to wait on is the name property, which gets mapped to the display text, right? I'm going to wait on this to be available to me before I proceed in my test. We have a bunch of wait for classes. So wait for control being ready, wait for control being enabled, wait for control property being something. It just helps you wait. It just helps your test execution wait for a certain condition to be met before the test proceeds. Helps you eliminate all sorts of timing issues that you might encounter. Yes. I'm sorry?
How long is it going to wait?
That's a great question. We also have a timeout defined. I think by default it's 2 seconds. I'm not sure on the timing that we have there, but you can override and wait for longer or lesser time depending on your needs. Again, some draw highlight just to make sure that my demo runs a little slowly, and finally log out and close the app. So let's go ahead and run this one. Highlighted that logout button there. The draw highlight makes the playback wait for about 7 seconds. Everything passed. My test is good.
So how do you get to the unique ID of your app when you install it? I mean, it's now tied to just a particular install of the app.
It is.
So how do you know when I want to do a fresh install and then know the ID that I want to run?
I believe that the way that that app ID is calculated is based on the certificate that you use to sign your app and all the stuff that you specify in the app manifest. So no matter how many times your app gets installed, it's going to get the same ID. Yeah. Yes.
The draw highlight pauses the test. Is there a way to switch the run mode so that the draw highlight, like once you debug your test, make sure it works properly, turn off the draw highlight globally so that your tests run much quicker?
No, we do not have that capability. Draw highlight is typically used for quick troubleshooting while I'm still building my test. Once my test is robust enough that it runs, people usually just turn that off. So we have
Turn it off by commenting it out?
by commenting it out, yes.
Okay.
Yeah. So a quick recap of what we saw in Coded UI test. We saw the new project template. We looked at the new specialized classes, the XAML, HTML. Of course, HTML is not new. We already had that in the context of web apps. And the direct UI controls for shell controls. We also saw support for touch gestures. Again, some demo slides to help you refresh your memory on the code syntax. We looked at the shopping cart scenario and the shell controls. Quick recap of everything that we saw here today. We looked at the several improvements that we made to the unit testing framework. We saw that the unit testing framework is extensible, and you can share the extensions that you write as NuGet package. We also looked at the end-to-end testing using coded UI test. Coded UI test now comes with support for gestures. One thing that I forgot to mention is similar to the unit testing framework, coded UI testing framework is also extensible. So if you have custom controls from any of the vendors, or you are developing your own custom control, coded UI test does support extension plugins so that you can do rich validations on these custom controls as well. And we are done. Ready for questions.
So wouldn't it rate with continuously rate with that?
Yes. So armed with this, now you can actually go and integrate with your build system in TFS. You can set up your build service to use these tests and run them as after the build is executed. I have another backup slide here. I wasn't sure that I would be able to show it to you. So let me bring that up here. So trying to run continuous integration tests with Team Build and Team Foundation server, that capability has existed in 2012 as well, but it was a painful process. You had to read a 3-page MSDN documentation, go through a bunch of steps manually, and of course that was error prone. The steps that you needed to do was install the developer license on your build agent machine, install the certificate in the trusted root store, run the build agent as an interactive process, and then change build definition to pick up the apex that the unit test build spits out. Right? We've made it a lot easier in Team Foundation Server 2013. We make it easy for you. It's all there in this one dialog. I've highlighted it here. You can just install and renew your developer license right here. You can also do that, manage your certificates from here, and everything is great. Cool. Yes, please.
I have a couple of questions about coded UI. First, does it support JavaScript or C++ applications?
C++ applications that use XAML are supported.
Okay.
WinJS JavaScript applications are not supported today.
And my other question is, would this work for black box testing when I don't have the source code of the app?
If you do not have
the source code.
The source code of the app. Yes, you can absolutely do black box testing. The only requirement there is that your app developer would have set some of those automation properties, the accessibility properties correctly.
Okay, thank you.
Yes.
What is the overhead, runtime overhead of the unit test framework?
Okay. So your question is, what is the runtime overhead for the unit testing framework? Compared to what?
Compared to the app itself running.
Well, I don't think it's an apple-to-apple comparison, primarily because in your unit tests, you would have isolated dependencies by using a bunch of stubs like I showed today. I don't think you can really compare one with the other. This is my contact. If you need to reach out to me, please feel free to send me an email. There's a bunch of related sessions.
Hi, I had a question for you. Is there support for this for building Windows Phone 8 apps?
Windows Phone 8 apps are not supported today. It's on our backlog.
Do you know if that's going to ship with 2013? Or?
It is not going to ship with 2013.
Thanks.
Yes.
Do you have a way to add jobs to an app?
I'm sorry, can you please repeat that question?
You shown the XAML window
Launch? Uh-huh.
but it doesn't accept any power reserves. So is there a way to launch an app
Uh-huh.
So I don't have to change the lead machine or the test machine in which test my app in composition. So I can launch my app with a language parameter, and my app is just showing and launch the test.
No, we do not have overrides for the launch method today. Typically, you would not do that via the API because the way your app would get displayed would depend on the OS languages itself. So whatever language you are running your test on, that appropriate language your app would show up, and you would be able to use your test that way. Yes. Uh-huh. We do not have support for running on ARM today. I'm sorry, I should correct that. We do not have support for running coded UI test on ARM today. You can run unit tests on the ARM device.
Can I get any kind of code coverage results?
Code coverage is not yet done for Windows Store apps. It's again on our backlog. Yes, please.
Does coded UI work with the simulators?
It does not. You need a machine to run coded UI tests. Yes, please.
Is any of this available outside the environment of Visual Studio so you can have an automation environment and you do testing?
Yes and no. So in order to author your tests, you would need to use Visual Studio and do that, right? Once these tests have been created, you would have your build system, and then you could actually integrate that with your test cases in the Microsoft Test Manager, and then run them via the Microsoft Test Manager. Yes?
Is there anything stopping the end user from interacting with the UI while you're running?
Coded UI test does take control of the input subsystem.
Okay.
So yeah, while your test is running,
The UI while it's running or anything along those lines?
yeah, you would not want to use your mouse or do anything with a test while it's running.
Can you put breakpoints in while you're running the tests and things like that?
Oh yeah, absolutely. The regular features that exist in the Visual Studio IDE, debugging, all those capabilities translate as is to unit tests as well as coded UI tests. Yes. Yes, like I mentioned, the extensibility point basically exists for custom controls. So if you no, you could write your own code, but the builder will not generate. Mm-hmm.
When you have a deeper hierarchy defining control, it may be complicated for him to define it. So what I wanted was to tell him you have to use this property and this property.
Mm-hmm. Right. So the way to do that would be to actually use that second option in my initial dialog, which said manually edit the test.
But for a user that is not a developer,
Uh-huh.
end user,
Yeah, there isn't a way to do that today.
Is it possible to distribute tests over VMs?
Distributed tests. Distributed testing is not supported on unit tests today. UI tests can be distributed using the test controller test agent that ships with Visual Studio. You can collect results from all over the place, yes. So we are out of time almost. One last question. Okay. Thank you very much.